Hello class, how's it going? In this video we're going to look at how to do a correlation using Excel. There's a few ways to do it, so we're going to go through all three ways and then also the way I think that you should do it because it's easiest that way. In addition to simply finding the correlation coefficient, we're going to test the correlation for significance. And we'll talk a little bit about what that means. But let's just go through the steps here. So if you'll recall from the known alternative hypothesis video on correlation, I've set up a situation where I'm a basketball coach and I'm curious if shooting percentage has any correlation with total points scored on the season. So in this column here, we've got shooting percentages for 15 players. And I've just selected them at random from NBA statistics. So I just picked, let's say, 15 players in the NBA right now. And they've all played 82 games. So that's what this column is. It's just shooting percentage expressed in decimals. So, 0.41 would equal 41%. In this column over here, column A, I've got total points scored on the season. And that's just the total points that they've scored over 82 games. I've calculated some means, so I've got a mean shooting percentage here of 43% or 43.8%. And on average of my sample, I've got, they've scored about 1,000 points on the season. So 196. Standard deviation, pretty different numbers. This is an example I'm using. One of the reasons I'm using it is because you've got two different kinds of numbers. You've got some big numbers and some tiny numbers, but the correlation still works, despite all that. And so this is a good example to show that it's really about the relationship between each of these. And you can kind of imagine this being put on a scatter plot or something to show. I mean, even though these numbers are very small, these numbers are very large, you can still plot it out in a way that would show this correlation visually. At any rate, standard deviation. So tiny standard deviation here because we've got small numbers. So most of these are clustered pretty closely around this mean shooting percentage, and that makes sense because in pro basketball it's hard to score because everyone's good, but no one's really that bad because everyone's good. So you're not going to have someone out there shooting 20%, nor are you going to have someone out there shooting like 68%. That kind of thing rarely happens. And then here, total points scored, if you extrapolate that over like 82 games, it probably comes out to like 8 or 9 points a game or something. So, I mean, most people, in pro basketball, there's a few people that score a lot of points. There's a lot of people that don't score that much. Not everyone gets to play the same amount of minutes, and not everyone gets the opportunity to score that much. So anyway, that's our data, and let's move on. Let's talk about something more interesting. I'm going to go ahead and just sort of delete this field here, delete this cell, and that is the correlation function we're about to use. So one real easy way to do a correlation in Excel is you could, and this is the one that's on your Atomic Learning tutorial, you'll find it's kind of limited, but I'll just demonstrate it here. You can use the correl function, and that just returns the correlation coefficient between two data sets. So this gives you the basic Pearson's correlation. Let me just select my data set here. So again, you get the parentheses, you have to fill out the fields. I pick the first data set, which is my total points. I pick the second, which is my shooting percentage, and I hit enter. Okay, so here's that number we saw, 0.63. So our correlation coefficient is 0.63, And as you'll recall from the reading, anything above 0 is a positive correlation. 1 would be a perfect correlation. Anything below 0 would be a negative correlation, and -1 would be a perfect inverse correlation. So here, we've got a fairly strong positive correlation at 0.63. Now, one of the issues with a correlation is that you don't really know if that's significant. I mean, you could say that there's some correlation there, that there appears to be some relationship between shooting percentage and total points scored. But you don't know if that's just due to chance. I mean, it's possible that I just picked 15 players that, for whatever reason, those 15 showed that relationship. There could be a bunch of people I didn't pick that shot a pretty poor percentage and then scored a ton of points. Like I could have just somehow missed them in selecting the data here. So though I have a Pearson's correlation, I don't really know if that's significant, and it's kind of tough at this point to really make any strong inferences from that data. So we're going to take it a step further, and this is something really easy for you to do in your data analysis project here. And what we're going to find is that it's actually, there's better ways to run a correlation in Excel. So we're going to just kind of go through those real quick and talk about them. So you've got this data analysis tool pack. Again, you should have enabled it by going to File, to Options, to Data, to Add-ins. Okay. Little blip there on my radar. Yeah, so if you go through all those menus, you get to Analysis Toolpack, and you want to have that enabled. Okay, so I showed you that in the first video for histograms. You're still going to want to have that done here because it's pretty cool. As cool as cool for guys that do stats in the middle of the night, I guess. Alright, so with our data analysis tab enabled, and so, again, how do we get there? Instead of just being at the home screen, we're going to bump over to data. Data screen is a good screen to work out of when you're doing stats, right? So that's where you're going to find it. So data analysis. I get into this tool pack. I can do a couple things here that are cool. One thing I can do is just do a fun little quick correlation. So there's another function to do a correlation here. What am I missing here? Let me just try this again. Here we go. So I'm going to select an input range, and with this data analysis correlation, it's a little bit of a different wrinkle because you've got to go ahead and get both columns in there. Alright, so once you have them in, you're going to group it by columns, and that's going to allow the program to separate them into the two data sets that you want, the two categories that you want. You can just go ahead and pick any output range. I just have it. What I do is usually just click on a square somewhere. Gives me a place to put it. So once I have that done, I can just click OK, and I get this little table here. And you'll notice that the correlation it generates is the same as this Pearson's R. So same number. And again, just the rest of this column really just shows that, or rather the rest of this chart just shows that there's a one-to-one correlation between this and itself and this and itself. And what we're curious about is the correlation between the two data categories that we have. So that's one way to do a correlation. Doesn't tell us anything new, though. It doesn't tell us significance. I just kind of feel obliged to show you this. But let's do something. Let's do something that matters, Dr. Alpage. Okay. If you go to this regression function in the data analysis toolpack, okay, and I've already done this once, so it's got existing stuff here. Let me just clear that out. All right. If you go to this regression function, what you can do is it's kind of the same deal. It gives you some input ranges, and what you're first going to do is run a correlation. All right, so you input your Y range, you input your X range. It doesn't matter which is which, because whether you choose one to be Y or one to be X is arbitrary. So you get that done. You can include the labels if you want. I just don't. This is not something I do. And then you're going to select an output range. And again, I'll just pick like any square. I'll pick this one. All right, and that's really all I need to do here. I just have to get it in, get my ranges in properly. Pick my output range, and then the program is going to do the rest for me, and it's going to do some cool stuff. Okay, so what is all this? A lot of this is kind of just extemporaneous stuff that you don't need in a correlation situation. If you were running a linear regression and you had multiple variables, what you would be doing is comparing all of the, looking at how each variable contributes to the relationship. We only have two, so we're not interested in a lot of things. You'll see that there is a little ANOVA table, which is an analysis of variance. All that's really doing is just analyzing variance. And in a sense, that's all t-tests do, is they just look at the variance and they determine if things are different. All this is kind of doing is mapping a t-test into a correlation. That's kind of how I think about it. But there's two things I want you to look at that are really important. Okay, the first is this multiple R. This number should look familiar. That's your correlation. That's your correlation coefficient. That's what you need. So that's one thing you need. And the other thing you need is down here, this p-value. Okay, so the p-value it appears here, this 0.01, and it appears here in the significance of f. That's going to be your p-value for your correlation. So we can see in this case, if we, for example, chose an alpha level of 0.05, right, which is standard for a correlation, our significance level is 0.011. Right? So what this tells me is that this correlation is statistically significant. That the chance of this observation happening just at random is pretty small, statistically speaking. It'd be pretty rare to, in any kind of data analysis, to have this strong of a correlation with this many samples. So one of the things I can conclude here when it's all said and done is that I've got a p-value of 0.011, and that's less than my alpha level of 0.05. So I'd be fairly confident in rejecting my null hypothesis, keeping in mind my null hypothesis for a correlation is that there's no relationship, and my alternative hypothesis is that there is a relationship. Given that the chance of this observation occurring, if there were truly no relationship between these variables, is like a 1% chance, I'm inclined then to reject the null hypothesis and accept my alternative. So that's a way that you can go ahead and do a test of significance in addition to just finding a correlation coefficient fairly easily in Excel. And in fact, you could probably just go right to the regression, get your correlation coefficient, right, and then go ahead and get your p-value, which is found in this part of the table, and it shows up again down here. So that's a technique for you to use. Take care.